I've discussed the iterative process of error checking and reality checking as we go, and we're at that stage where in our process that we will add our first round of dimensions, and we've set up the views pretty much how we think we need them, but as we go through the dimensions, really this is our working document. We're trying to communicate the best we can that what is needed for the manufacture of this part. So since we created a couple of other sheets with the left and the right view, or the front and the back view as the case may be, um, we can go ahead and put some of the overall dimensions, and we'll just start placing what we think will be a good start. And I am in metric. I could leave those in metric for now. And let's see, there's that little bit of a cap there, so we'll watch for that one. Let's see, we have an overall. Maybe we'll put the overall down here. And the height, our rule is if we don't put a dimension on a view, we probably don't need that view. So a lot of these are just reference for our sizing and for the overall. So maybe I'll take that one, just delete it and place it over here so that I can say I've applied something to that view, but it's not really super critical. All right, so our dimensions, our shapes. Um, we'll go back over to the front view, and really, since that has a label on it, let's go ahead and hit Control C. And I want to make sure that I'm calling them the same things, so Control V. And we'll put this somewhere where it's not in the way. And the back view, Control C, come back over here, and Control V. So I want to check, since the annotation doesn't move with that view, I'm going to go Control X, make sure that view is highlighted, and then paste it back in. Alright, so now if I need to move that view, those annotations should move with the assigned view. So our on this pass, we're putting in the dimensions. We're getting everything of note. There's enough geometry here that we're going to probably need to do this as ordinate. If I stack up all of those linear dimensions, it's gonna get pretty complicated. So the other thing of interest would be picking a datum. If I wanted to, and this is where the stack up comes in, maybe we'll go ahead and so I can talk about it in inches. Inch, pounds, and seconds with 3 decimal places. So we'll go to the tightest, but if we loosen up some of these dimensions, then that makes it easier to manufacture, a little more variation. But then we also have to consider the datums, that there's a possible positional shift, that if I in this view pull the datum off of this end and go this way, and in this view pull the datum here and go this way, that there will be a misalignment. So the purpose of our datum is to say that if I'm going to choose this end or this end, I want to be consistent in that geometry. So that means over here I would go let's say right to left, and setting a 0 in all of the dimensions, and here left to right. So when it turns over, I would have to change my coordinate system. But from an inspection standpoint, they're all coming off of the same side, and if there's any shift between those two side frames, then it would be minimized. So let's go ahead and put some ordinates on here. And to get into the ordinate dimension, I'm going to do the pull down. and I want an ordinate, and we're going to place the 0, and then the advantage here is I'm just going to go along the geometry that is in this view. So I don't want to pick that one up because it's actually in the back. If I duplicate that particular dimension, then I'm going to set it for reference. The other view has that same geometry, and it one of them has to take precedent. So let's see, from the bottom, I went back into the standard. I want to go into the ordinate, and usually I try not to mix dimensions. And if we go that way, and then that way, and then that way, well, we're sort of back to that same, just so it's on the same sheet, I don't have to refer back to this sheet for everything, but I can say the other one has priority. All right, so we need to get into the whole callout, and we'll pick the the half 13s, and then the quarter 20s, and then that makes pretty good sense. Let's see, anything I missed? So pulling those all the way across has advantages and disadvantages. You can see here that there's kind of it gets a little messier with all those lines crossing, but then it's a little easier to understand that those are vertical, not making an assumption. So let's look and see what it does on this side. All right, so back into the ordinate, and as I mentioned, when this turns around, this becomes the ordinate in this view. All right, so we're pulling off of that same edge or that same face. And let's undo that one. Oh, it got me out of it. So when I want to get back into an ordinate, we're going to right click on one of the dimensions, add to ordinate, and then we can keep on going. So with, let's see, that one's in the other view, current view, and then the overall, we'll set that one as a reference, and then escape. And if I go back into, in this case, the more dimensions just inside my frame on that one, we'll go this way. And on this one, I'll pick on the sides. Let's see, you can see the difference in going all the way across, and it helps with the colors, which we'll do as an optional little more geometry type later on. Okay, let's find one that's a little cleaner. All right, so our other, the steps, that was kind of hard to read with the isometric view over here. That helps. Some of the geometry that I missed then, going back through, we'll go into the smart dimension, and we're going to have 1, 2, 3, 4. So since that did not end up with a count, I'm going to go 4 times. I think the standard is moving away from typical, so we'd like to call it out specifically that we're looking for 1 or more. So 1, 2, 3, 4, and then that one's just weird anyway. So in this view, there are 4 times, and that may have been one of the reasons that the book did it the way they did it. Is this geometry in the background, even though it shows up in this view, doesn't really help. So a section view, eliminating that might make it a little bit clearer, but if I'm looking at my geometry, I'm okay with that. All right, so again with the smart dimensions, I would have a lot of geometry. Going back into the ordinate, we'll pick the 0, and at first we'll just go all the way across. And if I hold down the shift, I can get the terminating. But realistically, I think the tolerance is going to be driven by that one, so maybe that is a reference dimension as well. So the stack up, or my only concern really there. Let's see, get back into the annotations. Where did I? Oh, we need the. Now we'll just go back into the smart dimension. So if I do that, radius of 1 inch. Drives that geometry and should be that plus that equals that, but those two are kind of in that duplicate sort of gray area, so I'd rather not duplicate those. All right, so back to ordinate, pick up that side. Should be able to go down through the geometry here, pick up some of these guys. And let's see, I already grabbed, I grabbed that one, so should just be able to hit delete. Made that one a full radius. So other than the setup, let's go ahead and put one there. That didn't. So it doesn't look like I put one down there. Maybe I'll go back and select and add to ordinate. Drop that one in there. Oh, and that one went to the centers, and since there aren't any centers. All right, so I'll get probably more than I need to start with. And then when I go back through, there's always something that you see or pick out that you didn't on the first go around. So let's go ahead and just drop a bunch of these in. They're not overlapping too bad. There are times where the dimensions can get a little strange, and I'll do the shift again. I think I'm going to want to put the reference, and then we'll go back into smart dimension. Did I get my symbol? It's picking up too many things. Nope, it was just not grayed out. So we'll go 1 inch there, and then we had a typical 0.5 between the angles, so there's kind of an assumption of tangency there, and maybe on the other geometry. So that would be a toss-up. Usually I'd probably just go ahead and stay in the ordinate just so it's consistent. All right, let's go into next one. This we should be able to, since the faces are not critical geometry, this one is going to be a tolerance, so I know that I'm going to come back later. I'm going to want to put an inspection dimension on those, and they're probably going to be the same. Since it was built into the geometry, I don't think we're going to get an instance count for the holes, but we can try on that one now. So this one had 3, 4, 5, 6, 7, 8, 9, 10, 11. And yes, I want to continue. And they're pretty much all on the same center line. If we wanted to call those out a little bit better, and this is kind of in that could go with the typical, but I think we're going to be in the better practice of saying there is -1 space to the number of holes, and then from the spacing we could just go 1 inch, and that should give us enough information to pull those items. All right, so the next ones are pretty much going to be the same. I'm going to speed up a little bit just to build these guys out. Now go back and grab those when we set the tolerances, and a through hole, and a thickness. And based on the thickness and what that does, I would want to use whatever material came in. So 1/8 inch material comes in, say, 120 to about 130, depending on how it's defined. Right, so manufacturer and whether it's sheet or plate or just whatever. So there is some variation. I'd like to leave that with a tolerance that we could use raw stock and not have to machine it if it didn't need it. All right, and then our overalls, outside dimension, side, because we have the hole call out, we'll go that way. And then pretty much the same thing back into the smart dimension. And we would need to look at this from a tolerance standpoint because I haven't really gone through the materials. That's kind of the next with the tolerancing. I'm going to have to make some decisions on materials, assuming that these are a mild steel or possibly a stainless steel. Then that would drive some of the manufacturing. I got ahead of myself on that one, so we'll delete out the 136, which is the tap drill, but I want the whole call out to pick up those other geometries. All right, and then our spacers and width and diameter and width. All right, so as we go through, I think that got all my sheets. I want to make sure to save it. All right, so our first pass, that's a pretty wide open tolerance on the spacers, so don't really need anything there. One quick, this diameter will need an inspection because it's going to be part of the bearing surface. Oh, not a reference. Inspection, so the operounder containing it. So I'm kind of leaving breadcrumbs for myself to, on the next pass, make sure that I don't miss anything important on these geometries. So okay, we did that one. The radius, and oh, I guess it would have helped to. So like I said, you never really pick up the what did I miss until you go back and find out that you missed it. All right, so wide open tolerance, and we have 5 times on that one. This one was a 780 and that one was the 5/6 through, so we'll try and sneak that one in there. Try not to make it too crowded. All right. I think we got all of those, and these are just tapped holes. Nothing really toleranced. We'd probably go back through, and we're not really going to measure the rounds to 3 decimal places, so opening those up says it's not critical. Blend them, make them look nice, but for the most part, they're not a toleranced item. Sort of like chamfers in that respect of putting 4 decimal places on a chamfer or 3 decimal places on a chamfer is pretty useless because it makes it a lot harder to measure and verify that the geometry. So it's going to end up costing more. All right, so I think I've gone through, and for our purposes, that fulfills the requirements of the assignment. The next videos will be optional and deal more with the tolerancing and the thought processes behind how to make this assembly. And then future videos will be a redesign for current manufacturing capabilities. So we'll end it here.